Hi, welcome to this particular module. So, when you talk about wafer cleaning and pre-baking, silicon wafer cleaning methods are scrubbing, air bubble jet, high pressure rinse, sonication at 1.5 megahertz, followed by dehydration or pre-bake and primering, high temperature baking to remove moisture as we have discussed earlier after the wafer cleaning process, and then we had to use a primer coating. This primer coating is to improve the adhesion of photoresist, and this primer is hexamethyl disilicene, which is HMDS in short, and the temperature can be 125 and above. Some people also use at 200 degrees centigrade to 250 degrees centigrade for 1 minute on hot plate. This is to improve the adhesion, right. Now, photoresist, when you come to photoresist, the photoresist is a polymer which is solid organic material and is used to transfer the designed pattern to wafer surface. The change is, it changes its photosolubility due to photochemical reaction exposed to the UV light. So, what should it have? It should have a high resistance and good adhesion. These are properties, okay. And for this, first is that we have to hold the wafer onto a vacuum chuck and then dispense 3 to 5 ml of photoresist, then slow spin at 500 rpm followed by a higher rpm or ramp up to from 1100 to 5000 rpm. Photoresist is sprayed by centrifugal force. We will see as photoresist spin coating schematic in the following slides. And the quality measures are the thickness, the time, speed, uniformity, while particles and defects are something that we need to also understand, because the particles and defects will destroy your overall pattern. There are several kind of positive photoresist as well as negative photoresist which are listed here. As we discussed earlier, the mask are of two types, either it is bright field mask or a dark field mask. If I use a positive photoresist, then I can replicate this pattern as you can see here. If I use a negative photoresist, the reverse of this pattern will come, which you can see in this case. So, exposure to UV light remove resist, exposure to UV light maintains resist, right. You can see very clearly that the photoresist is intact in this case, because it is not exposed to UV light. This is your positive photoresist. When the photoresist is exposed to UV light, in case of negative, it will become stronger, the unexposed region become weaker. Again I am repeating, the unexposed region in the mask in case of positive photoresist will become stronger, while the unexposed region in the mask for negative photoresist will become weaker, right, stronger, weaker, easy. Now, this is the schematic of the photoresist dispenser, where you can see there is, it is connected to a vacuum pump, there is a spindle for spinning it, there is a vacuum chuck so that wafer will not fly, and then there is a photoresist dispenser. This wafer is held to the vacuum chuck with the help of vacuum. We can dispense anywhere around 5 ml of photoresist, and to have uniform spin coating, we can start with 500 rpm, which is slow spin, followed by 1000 to 5000 rpm, which is ramping up, and as you understand, the centrifugal force will help the photoresist to spread. Again the quality measures are same which we have discussed earlier. So, why to perform soft baking? Soft baking is generally done at 90 degrees centigrade, right, for 1 minute on hot plate, but depends on what kind of photoresist you use. If you use SU8, this is different than compared to positive and negative photoresist. So, but the point of soft baking is so that partial evaporation of photoresist solvents, it improves the adhesion, improves uniformity, improves H etching, H resistance. What is H resistance in this case? That if you see this slide, H resistance is when if I have a metal, right, if I have silicon, let us say oxidized silicon, on this I have a metal, on this there is a photoresist which is patterned like this, okay. So, this is a photoresist, this this is my metal or material, this is silicon dioxide. What is etch resistance? Etch resistance is that if I dip this wafer in a metal etchant, then it will affect photoresist, but it should not affect that greatly that the metal below it will get etched. So, it is resistant to the etching material, right, that is your etch resistance. Also soft baking will improve the light absorbance or optimizes the light absorbance, and finally the characteristics of photoresist should be that it should be particle free and defect free. Now let me play 2 videos for you, so that you understand how to spin coat the photoresist. So let me play the first video.
Hello and welcome to this training on our lap spin 2 and 3, the manual spin coaters. Today we will be talking about the spin coater itself, the hot plates, different types of ball sets, how to do the spin coating and the cleaning afterwards. In the ball sets we have a ball, we have a splash ring, then we have different sizes of chucks, a 6-inch, 4-inch, 2-inch, then we have small chucks for bits and pieces. Normally we have a 20mm and 12mm. In a special holder in the chemical cupboard we have a box looking like this. It contains normally 2 or 3 chucks. We have an edge handling chuck that is only handling on the edge of the wafer. This one can maximum be spun at 3000 rounds per minute. Then we have a 2-inch where the pins has been removed just to give a large area for large substrates, and there should be a second chuck which is even smaller, that is only like 5 by 5mm in total. The ball sets are in these different drawers. Down here we have the ball set itself. When we take it out we need to use nitrile gloves, clean nitrile gloves. We open the sash and put it inside the fume hood before we open it. When we handle things on the outside it is nitrile gloves, the same on the sash and on the panel board and on the spinners, but as soon as we handle the ball set itself we need to have 4H gloves or barrier gloves. We have different ball sets that are depending on which chemicals you're using. If you like today use UV resists, which is the solvent PGME and cleaning solvent acetone, then you take this ball set. It is important not to mix up ball sets with different chemicals. Before we start the processing, it's a good idea to turn on the hot plates. On the green button here, you turn on. Then we have to put a set point. So we have an aluminum cover plate that is changing the temperature by 10%. So hold in, set, and then change the value that you need. So for 90 degrees, I would go to 99 degrees. We have 2 different hot plates. We have one that goes to 110 degrees and one that goes to 250 degrees. When handling the ball set, we always use nitrile gloves on the outside to take off the lid. Always have the sash at chest height to not make dangerous fumes come out to everybody. Then we take the inlay set, the ball here. The nozzle goes into the hole down here in front. The splash ring, the protruding side goes downwards. Make sure that it's fixed correctly. And then a chuck here has a small recess, and we also have a small pin down here, so make sure that the pin is correctly, you adjust it and then place the chuck underneath. And when you then push down, make sure that the chuck goes all the way down so it's fastened on the spindle. Whenever you have taken the chucks and the ball set, please take the box and put it back into the drawer so that you have room. Every time you handle it, make sure that the lid is on and only open the box inside the sash. Now we're going to do processing, so I'll talk about the spin coater and how to set up recipes and quick start. When we need to do processing, I would always make a small workspace, a piece of paper, put on your resist and either disposable pipettes or this disposable plastic bottle. Never use the glass bottles because then you contaminate them. We will open the spin coater, take a substrate, and place on the chuck Make sure to use the centering pins so that the chuck is leveled. Close the lid. Go to quick start and start a random process. This will show us that the vacuum is on and the time is starting. The wafer is rotating and we're just checking that the vacuum level is okay. The touchscreen itself, there is two things to be aware of. Quick start, which we just used. Here you can select the time that you need to spin coat. So 60 seconds, for example. You can select the speed, which gives you the thickness. In this case, 4000. And the acceleration, normally between 500 and 1000. But it's depending on your process. When you click start, you can also do processing. And of course, we need to dispense first. We could also use a recipe if we need to make more than one step. We go to recipes, go to the bottom, find an available slot. You could also use the pin. When you click an available one, you can give it a name. So let's call it test. And if you click the number out here and edit, then we can change the actual parameters. So here we could start with a small spreading. So let's say 30 seconds at a very small speed. It's just to disperse the resists and a standard acceleration. Then the next step would be the actual thinning of the resist, the spin off. And of course the acceleration. If you start this process, it will go through step 1, 2 and how many steps you have made. It is up to you if you do a recipe or a quick start, it gives you the same results. When we are starting a process, open the lid. First, I would show you how to pour from a plastic bottle. So you have the resist with the proper markings. Pour on a little bit in the center. Try to make a uniform circle. Close the lid and press start on quick start. When we're spin coating on a smaller substrate, we have chucks of different size. So select the right chuck for the job. Again, find the recess and the spindle. When working with a chip, we take a chuck of the right size, place the chip in the center, close the lid and start the quick start, just so we check that the vacuum is okay. This is important because if the chip is misaligned, then we will have a resist soaked chip, which is very hard to control. When you're working with disposable pipettes, always clean them with nitrogen to remove excess particles. If it's a E-beam process, I would recommend to use 20 seconds of nitrogen air. When taking resist from a bottle, use the disposable pipette. Never touch the bottom nor the sides. The pipette goes in the middle, just below the surface, and you suck up the amount that you need. On a chip, I would always recommend to fill the entire chip. Make the first 2 or 3 drops go in the ball set. Fill the entire chip as much as possible. Sometimes you may need to take several times in the bottle. Make sure that you have a couple of drops or maybe even half a milliliter left. Close the lid and start the process. When the spin coating is complete, we open the lid, take off our sample and put it on the hot plate and start the timer. When the process is done and the timer stops, we take the sample to the edge and pull it off onto this cooling block. Just a few seconds until it's cold. When the process is complete and we need to clean, open the sash into the cleaning fume hood. Remember to open the fume hood so that you can transfer your inlay set. Now it is soaked with chemicals, so always wear 2 forage gloves or barrier gloves. When disassembling the inlay set, first take off the chuck, pull straight up here. Make sure you have a tissue ready so you don't spill on the way when you transfer your bolt set parts over to the other fume hood. If there's a lot of resists in the bolt set before removing that one, it's a good idea to take a tissue, wipe it off just like this, just so we don't have as much liquid resist. Discard this one in the solid sea waste. Remove the splash ring in the same way. Make sure that you don't drip on the way. And at the end, remove the bolt set. Here it's important to have a piece of tissue underneath the nozzle so that we don't drip resist all over hot plates. Always remember to turn off the hot plate when you're done. When we're doing cleaning, we're working with dangerous chemicals, so put on apron, face shield and forage gloves or barrier gloves. It's a good idea to take up the bolts or the box that you need for the bolt set in advance, open it with your nitrile gloves, then you can displace your stuff immediately. Take, for example, the bolt set or the chuck, doesn't matter, and clean it properly with the cleaning agent. In this case, it's acetone based, so read on the bolt set which cleaning agent you're using. Then take the solvent, put it on a napkin like this. Make sure if there's some drops, it's placed on napkins. Make a workspace for yourself in advance with clean napkins, and then wipe everything: the bowl, the inlay, the splash ring, all the chucks, inside, outside, nozzles, everywhere. The longer you wait before you clean, the more fixated the resist will come, and therefore you may need to use a little bit of time on the cleaning. Remember to also clean the inside of the nozzle from the front and the back side, so there's no resist residues left. When you're done with one part, just put it directly up into the box and then continue with the next. Sometimes the resist is sticking very well on the surface. Just make sure to apply plenty of solvent and give it a good mechanical scrub. When cleaning the chucks, make sure that you take the top, the sides, the back side, and also the recess, because if any resist gets in here, it acts as glue and then we cannot get the chuck off. When we have cleaned the chucks, we need to clean the actual spin coater. Remember to open the sash before you start. Also have the door open here, so you can use solvent in this fume hood and not in the wet bench. Put a piece of amount of solvent on the tissue that you want to use. Here, wipe the entire spindle, also the small pin, and the inside of the lid. Never the outside, but both transparent part and the white parts. Dispose all tissues in solid sea waste. When you're done with the cleaning, you can take off your apron and your face shield. The forage gloves should always be turned inside out, like this. Remember to always empty the sea waste when it's a lot full, or if you use dangerous chemicals. Always inside the fume hood, tie a proper knot so no smells escape. Grab a new sea waste bag and prepare the bin for the next user. When you're done with the cleaning, remember to log out of Lab Manager and fill in the logbook.
Okay, so you have seen the first video. Now let me play the second video, which is on Laurel WS650 HZ spin coater. The number is 61002. Let us see that video and then we will continue.
This is the Laurel WS650HZ spin coater. It has a maximum rotational speed of 12,000 RPM, The controller allows operator interaction in real time during the process execution, including pausing time, stopping, and continuing on from that point. The closed bowl design allows most coating materials to dry in a quiescent state, increasing uniformity and minimizing particle contamination. This convenient tabletop unit is powered by 120 volts AC, single phase. It also requires vacuum to be at least 15 inches of mercury or more. First, I'd like to give a demonstration of the speeds. For that, I'm going to use our little timing strip. First, this is the compact control panel, completely self-contained. I'm going to call up a program here, program 4, and what we'll first do is we'll change the spin speed to, let's say, 4,000 RPM. There we go. And then first we will apply vacuum. It tells us that we are ready. And we'll go. Okay, when it's done, in order to go on and run another program or any other process, you must open the lid. This signals it that it's ready for another run. What I'll do in this one here is I'll double that to, let's say, 8,000 RPM. And we will repeat. Lid. We're done. It'll always say done, and after you lower the lid, as long as your vacuum is satisfied and your nitrogen purge, it'll tell you that it's ready. We'll do one more spin, and we'll do this at the maximum RPM of 12,000. Done. Next, we're going to spin a small wafer to has this very, very nice little adapter here that you can fit right on top of the standard chuck. First we apply vacuum, and we'll spin this little wafer at the maximum speed. Now next, I have this chart here, and this is wafer size versus spin speed. Obviously, the smaller the workpiece, the faster you can spin, and they've given a little guideline here. First, we ran this little guy up to 12,000. Now we're going to run a 100 millimeter wafer, as suggested, up to 6,000. This is actually 150. We use a little 100 here. Vacuum, and we will also edit that speed down to 6,000 RPM. And here we go. Done. Turn off our vacuum. Move our wafer. Now, the spin coater has the capability of actually being able to spin a full 200 millimeter or 8-inch wafer. However, it is to be noted that in order to do so, you would have to remove the top and take off this plastic splash guard, because that just isn't enough room for it. But it actually has the capability of spinning a 8-inch wafer. However, what's important also in this particular unit is that it has the capability of spinning a full 5-inch by 5-inch square substrate. I have a piece of glass here that I can use to demonstrate. You center that respectively. And even though it's about approximately 7.5 inches across here, if you look through the top, it still comfortably fits in between the splash shield. Now I'm going to spin this one. Since this is closer to the very larger size, which they recommend between 2.5 and 3.5 KRPM, I'm going to spin this at 3,500. And here we go. Oop. Vacuum first. There we go. Ready, lights on. Start says yes. Very versatile, very compact, lightweight, fits in anywhere, and very easy to use.
Okay. So, now since you have seen the video which is of spin coating, the next step would be exposure. So, the exposure would be that you have the reflected light and then there is a lens, right. This distance is measured in terms of d. So, from the mask to the lens, what should be the distance between two is calculated using optical physics. We are not going into detail about this particular technique. However, this is just like a lens is there, reflected light is collected by the lens, and the ideal light pattern should be as shown here, but the actual pattern is what we get is as shown here, right. So, light source, you have light source, you have mask, bright field or dark field, and then you have positive or negative photoresist coated on the substrate. So, the less diffraction after focus by the lens. So, lens will help to not allow the diffraction to be larger area. And if you want to talk about developing, then developing you can see here, if you are concentrating on your time of the developer, right, then you will get the normal development as you can see in this case. However, if there is a if the time is less, there is a developer time for developing 1 micron of photoresist is 10 minutes, right, and if you take out the wafer before 10 minutes, then there can be incomplete development. However, if you also it can also result in a under development. While if you keep it for greater than 10 minutes, what will happen, that there will be over development. So, this all three cases, incomplete development, over development and under development is not accepted. The recipe should be for 10 minutes and you should just take out the substrate in 10 minutes. So, the along with the process flow, recipe is extremely important, right. So, this is one thing about negative and positive photoresist. Like I said, the if you talk about this as a mask and you see this is a photoresist, then if you in case of positive photoresist, let us talk about first positive. The unexposed region is stronger, then unexposed region is this black region, this one and this one, you can see it is stronger in this case, while the exposed region is weaker, we can see here in this case, correct. While in the case of negative photoresist, the unexposed region, which is this one and this one, will be weaker, which is here, and the exposed region, which is this two, is becomes stronger. So, exposed region becomes stronger and unexposed region becomes weaker in case of negative photoresist, exposed region becomes weaker and unexposed region becomes stronger in case of positive photoresist after photoresist development. So, if you remember this formulas or this what you call tricks, then it becomes very easy. It is not really a formula, but it is a trick to remember.